All right, today we're going to be learning about trapezoids and kites, and these are our Common Core content standards and mathematical practices we'll be using in our lesson today. Previously, you've used properties of special parallelograms. Today we're going to apply properties of trapezoids and of kites. We have 7 new vocabulary words today. Trapezoid, bases, legs of a trapezoid, base angles, isosceles trapezoid, mid-segment of a trapezoid, and kite. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases. The non-parallel sides are called legs. The base angles are formed by the base and one of the legs. In trapezoid FGHG, or HJ, I'm sorry, angle G and angle H are one pair of base angles, and angle F and angle J are another pair. If the legs of a trapezoid are congruent, then it is an isosceles trapezoid. So let's solve problems using the properties of isosceles trapezoids. You may want to pause the video for a moment and make a sketch and write down what is given so that you can follow along as we solve the problem. Each side of the basket shown is an isosceles trapezoid. If the measure of angle JML is equal to 130 and KN is 6.7 feet and LN is 3.6 feet, find the measure of MJK. Well, since JKLM is a trapezoid, we know that JK is parallel to LM. And so we can use consecutive interior angles theorem because we know they're equal to 180, and we'll substitute in 130 for the measure of JML. We simply subtract 130 for both sides, so we know the measurement of angle MJK is equal to 50. Okay, we have the basket again. If JML is 130 and KN is 6.7 and JL is 10.3, find MN. Well, since JKLM is an isosceles trapezoid, we know that the diagonals are congruent. So by the segment addition property, we know that KN plus MN is equal to JL. Well, we've got the measurement for KN and for JL, so we simply are going to subtract 6.7 for both sides. So we know that MN is 3.6. Okay, it's time for you to check your progress. So using the same basket, why don't you pause the video for a moment and work the problem, and then come back and check your answer. Oh, did you get answer C? I set 124 plus X is equal to 180, then solve for X. I got 56. Okay, now for another part of the check your progress. So pause the video for a moment, then come back and check your answer. Well, I know that 14.1 feet plus minus 9.8 feet will give us the measurement of IH. So that ends up with 4.3. Now you can use coordinate geometry to determine whether a trapezoid is an isosceles trapezoid. So take just a moment and jot down the information that's given and sketch your graph so that you'll be able to follow along as we work the problem. A quadrilateral is a trapezoid if exactly one pair of opposite sides are parallel. So we're going to use the slope formula. Okay, the slope of one side is 1/4 and the slope of the other. We've got 1/4, 1/4, -1, and 4. So exactly one pair of opposite sides are parallel. So AB and CD are parallel. So ABCD is a trapezoid. Now we're going to use the distance formula to show that the legs are congruent. So we're going to have to check all, okay, AD and BC are not congruent, so it's not isosceles. Time for you to check your progress. So pause the video. You might sketch your graph first, note what you know, and let me know. Is it trapezoid or not? Is it isosceles or not? It is a trapezoid because the slopes for the two sides are the same, but it's not isosceles. Okay, when I use the distance formula, they are not equal, so they're not congruent, so it's not not isosceles. The mid-segment of a trapezoid is the segment that connects the midpoints. As you see, here's a mid-segment. It connects the midpoints of the legs of the trapezoid. In the figure, MN is the mid-segment of trapezoid F, G, J, K. We're to find the value of X. So we know that the mid-segment of the trapezoid is equal to 1/2 of both the segments. 30 is equal to 1/2 times 20 plus X. Let's multiply both sides by 2. Let's get rid of that fraction. Subtract 20 from both sides. So X is equal to 40. Okay, time to try your hand at a mid-segment. So pause the video for a moment and then come back and check your answer. Okay, did you set your problem up? JK is equal to 1/2 of 25 plus X. So JK is 18. Since JK is a mid-segment, is equal to 1/2 of WZ plus XY. So we're going to start by multiplying both sides by 2. We'll end up with 36 is equal to 25 plus X. So we subtract 25 from both sides. We end up with X is equal to 11. Now let's look at kites. A kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. Unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. Its diagonals are perpendicular, and exactly 1 pair of opposite angles is congruent. So let's use the properties of kites to find the measure of angle XYZ. Since the kite only has 1 pair of congruent angles, and those are the angles that are between the non-congruent sides, we know that WXY is congruent to WZY. And WZY is equal to 121 degrees. So we've got 2 of the 121 degree angles, and we were given that we had a 73 degree angle. We know altogether the interior angle sum, they're equal to 360. So when we add these together and subtract them from 360, the measurement of angle Y is XYZ is 45. If MNPQ is a kite, find NP. Okay, so we know that these diagonals, they're perpendicular, so we've got some right angles in here. So we can use the Pythagorean theorem. So a squared plus b squared is equal to c squared. Take the square root of both sides. So we know the measure of that one side is 10. Okay, time for you to check your progress. This is the first of a couple. Remember that the angle that's between the two non-congruent sides, there's 2 of them. Okay, so pause for a moment, then come back and select your answer. Good job, 36. So I know that 130 plus 130 plus 64 is equal to 360. And when I add these up and subtract them from 360, my answer is 36 degrees. Okay, here's another problem. So pause the video for a moment and come back and check your answer. So we're going to use the Pythagorean theorem. We've got 2 sides, a 90-degree angle, so we can say 3 squared plus 4 squared equals x squared. Of course, if you remember your Pythagorean triples, you know that that's a 3, 4, 5. Very good. You're ready to begin the assignment.